swim. So, Chapter 5, Radians. Okay, let's go. Convert 135 degrees into radians in terms of pi. 2 pi radians equals 360 degrees. Thus, 180 degrees is pi radians, and 90 degrees is pi over 2 radians, and so 135 degrees is 5/8 of pi radians. Convert 5 pi over 6 radians to degrees. So we need to only find 5/6 of 180. 1/6 is 30, so 5/6 is 150 degrees. And so 150 degrees is 5/6 pi radians. Convert 300 degrees to radians in terms of pi. (300 degrees is 120 degrees more than 180. 120 degrees is 2/3 of pi radians, and thus it becomes pi plus 2/3 pi, which is 5/3 pi. So 5/3 pi radians is 300 degrees. Evaluate sine of pi over 3 in surd form. So pi over 3 is 60 degrees, and sine of 60 degrees is √3/2. So √3/2 is sine of pi over 3. Evaluate cosine of 3/4 of pi in surd form. 3/4 of pi is 135 degrees. And in the case of cosine of 135 degrees is negative √2/2. So negative √2/2 is cosine of 3/4 of pi. All right, number 2 is arc length. A sector has radius 5 centimeters and angle 1.2 radians. Find its arc length. Right. Right, so let's think about this. Okay, so what's the formula? Right, so let's try and remember the formula. What is it? If I know the angle, so 1.2 pi divided by 2 pi should be the answer. Something like that. The angle is 1.2 radians. Okay, so right, let's think. Alright, so in a circle it's 2 pi r. And 1.2 over 2 is 0.6 over 1, so 0.6. Okay, so the answer... Wait. Surely it's... Alright, so I've actually completely forgotten how to do this. So I need to remind myself. Okay, so the answer is that the arc length is the radius multiplied by the size of the angle in radians. And therefore the answer is simply 6. The sector has radius 8 centimeters and angle pi over 4. Find its arc length in centimeters. Okay, so what we do is 8 times 2 pi to get 16 pi, and then divide that by 8 to get 2 pi. 2 pi centimeters. Okay. Right, the language is unfamiliar, so I have to practice. An arc of length 12 centimeters subtends an angle at the center of a circle of radius 3 centimeters. An arc of length 12 centimeters subtends Subtends an angle. Subtends an angle. An arc of length 12 centimeters subtends an angle at the center of a circle whose radius is 3 centimeters. Find the size of the angle in radians. Okay. Alright, so the size of the entire circle would be the circumference of the entire circle would be 3 times 2 pi Alright, so this is going to be greater than 2 pi radians. Alright. Four radians. The answer is 4 radians. A sector has radius 6 centimeters and angle 0.5 radians. Find its perimeter. Okay. Okay, so the subcircumference part, or the arc length, should be 6 multiplied by 0.5, so 3, and then 3 plus 6 times 2 to give us 15. No, it's already gone. Let's try again. The sector of a circle of radius 9 centimeters has an angle of 40 degrees. Find its arc length in centimeters. Alright, so that's 1/9 of a circle. So 9 times 2 pi is the entire circle, so 18 pi is the entire circle. Then divide 18 pi by 9 and we get 2 pi. So 2 pi centimeters. Okay, next is areas of sectors and segments. Okay. A sector has a radius of 10 centimeters and an angle of 0.6 radians. Find its area. Okay, so how do you do this? The area of a sector when you know its angle in radians. What do you do? Okay, so you need to find the area of the entire circle and then find out what fraction that represents of the entire circle, and then multiply them together, but I've already forgotten, so I need to do it again. A sector has radius 10 centimeters and angle 0.6 radians. Find its area. Okay, so if it were 2 pi radians, its area would be alright, this is starting to confuse me now. I'm not sure why. Zero 0.6 over 2 pi multiplied by 10 squared. Surely it has to be this. And 0.6 times 10 squared is 60, so 60 over 2 pi, which is 30 over pi. Sector has radius 6 and angle pi over 3. Find its area. Alright, so that's alright, so pi r squared. Hello. So try again. Alright, so something isn't clicking for a second. Radius 6 and angle pi over 3. Find its area in terms of pi. Alright, so 36 pi over 6, so 6 pi. A sector of angle 3 radians and area 24 square centimeters in area. Find its radius. Right, okay. Okay, so it's time that we developed a formulaic way of thinking about this. Okay, so sector of radius r. We need to find its arc length. Okay. So So that's just r times theta. And surely it would be half r squared theta. I have to check. Yeah, half r squared theta. Okay. Alright, so not a successful run. Just the batteries are feeling low currently. The mental batteries. I need to recharge them.